Good morning. Today we are correcting PO73. I can calculate the probability of a single event. So in our last objective, remember, we had talked about having multiple events and how many outcomes there were altogether. This time we're talking about just a single event. So, Claire, you need to be paying attention instead of being goofy. Okay, remember when I said we're going to go over some of what we learned yesterday? So do you think you could even be writing down some of that? So remember, probability is the likelihood of the event happening. So we needed to look at what our desired outcome would be, what you want to happen, and that's going to be over the possible outcomes, the total number of outcomes that are there, what could happen. So we talked about rolling that dice. There are 6 possible outcomes. So that would be our bottom number. When we talk about rolling a 6, there's only 1 6 on there. So there's 1 desired outcome out of 6 possible. Right? So we always have to look. It is the desired outcomes over total possible outcomes. So somebody yesterday was talking about the odds, doing the possible outcomes over the leftover stuff. That's not what we're doing in this objective. It's the desired outcomes over the total possible. So we did the first page together. So let's look at our second page. What is the probability of choosing a vowel? We talked about how vowels, there are 5 in the alphabet because we didn't want that sometimes Y. We wanted the 5 regular vowels, A, E, I, O, U, out of 26. So we make our fraction. Then we do that fraction bar means we're dividing. We find our decimal. So it's 0.19. We take that 0.19 and turn it into our percentage, which is 19%. And that is not likely to happen because it's closer to 0 than it is to 100. So 19% means that's not likely. Anything below 50% is not likely to happen. Over 50% is likely to happen. Now, next one. What is the probability of choosing a consonant? Well, if there's 5 vowels, there are 21 consonants. Divide it by 26 and we get 0.81, which is 81%, which is likely to happen. What is the probability of choosing a letter before O? So you had to count from A to N. So going from A to N, there are 14 letters. So we have 14 over 26 letters total. Divide that and we get 0.54, which is 54%, which is likely to happen. What is the probability of choosing a letter in the words SVDP Royal? And we can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, and none of them are repeats. You have to be careful. If there is a repeated letter, you can only count it once. But he did not repeat any of these letters, so there was 9 out of 26, which is 0.35, which is 35%. 35% is not likely to happen. Any questions on our alphabet problems? Show me your thumbs. How'd you do on the alphabet? Okay, let's look at our cards. Remembering that last page, behind it, we have the actual cards in case you needed to use them for your work. So, what is the probability of choosing a diamond? There are 13 diamonds in a deck of cards, and there are 54 cards in the deck. Or sorry, not 54, 52. So if we counted all of those cards on the next page, there were 52. 13 divided by 52 is 0.25, which is 25%, which is not likely to happen. What is the probability of choosing a face card, the Jack, Queen, or King? We count those up and there are 12 out of 52. Divide that and you get 0.23, which is 23% not likely. What is the probability of choosing a red card? Oh, thank you. Sorry about that. Probability of choosing a red card, which would be our diamonds and hearts, or a spade. So there's 13 diamonds, 13 hearts, and 13 spades, which is 39 cards out of our 52, which is 0.75. And that turns into 75%. That is likely to happen. What is the probability of choosing a prime number card? So we need to know what our prime numbers are. So 1 is not a prime number. 2 is a prime. 3 is a prime. 4 is not. We can break it down to 2 and 2. 5 is a prime. 6 is not. It can be broken down into 3 and 2. 7 is a prime. 8 is not. It can be broken down into 4 and 2. 9 can be broken into 3 times 3. 10 can be broken into 5 times 2. 11 is a prime. 12 is not a prime. That queen is worth 12 points. That is 4 times 3, 6 times 2. But 13 is a prime. So our first prime numbers, I'm not sure what conversation is happening over there, but your attention should be up front. We have 2, 3, 5, 7, 11, and 13 are our prime numbers. So probability of choosing a prime numbered card, there are 6 of them in the hearts, 6 of these in the diamonds, 6 in the spades, 6 in the clubs. So that equals 24 cards in our deck are prime numbers. 24 divided by 52 is 0.46, which is 46%, which is not likely to happen. How many of us knew that there were 6 primes and we had to multiply it by 4 because there are 4 suits? So how many had 24? Did you had 24 out of 52, Melanie?
Yeah.
Dominic, you got that too? So can you wait till we're done correcting? So 6 primes, do you guys see how we got the 24? Because if we look at our cards, we can see the primes in that top row. We can see them, and that is for each row. So each row had 6 primes. And then we have to either add all those 6s together, or we could say 6 times 4. And that's how we got 24 primes. What is the probability of choosing a 9 or a black 5 or a red 2? So if we look, there are 1, 2, 3, 4 9s. There are black 5s. There are 2 black 5s or a red 2. There are 2 red 2s. So that is 4 plus 2 plus 2, which is 8. So there are 8 of those cards that we are desiring. So 8 on top divided by our 52, we get 0.15, which is 15%, not likely to happen. Claire. So we look at our cards and we look at what it is that we want from those cards. So when we looked at the first one, what is the probability of choosing a diamond? We had to look at our diamonds. So these are the diamonds. And we had to count how many of those cards there are. There are 13 diamonds in a full deck of cards. So we want one of those 13. So we have 13 possible cards we could choose that were a diamond. Madison, go sit at the front table. Uh-huh. Aaron, I'm not asking you to comment on it. Does that make sense? So that top number is how many choices would work. Yep. So how many letters out of our 26 letters in the alphabet, how many of them are in that phrase? So you have to count how many letters there are in SVDPROYAL. None of those are repeating. So how many of those letters are there? Yeah, we had to count up how many letters we wanted to, we had the option of choosing from, and that goes on the top. So that's how we got the 9. What's that fraction bar mean? Oh, 26? How many letters are in the alphabet? So if we put all 26 letters in the hat, there are 26 possible outcomes. How many total there were? So you always have to think how many total possible outcomes are there. That goes on the bottom. How many you want goes on the top. So 50% is half and half, 50-50 choice. So it could go either way. It's not likely or unlikely. It's right in the middle. So over 50 is likely to happen because it's closer to 100. Under 50 is unlikely to happen. Okay. Remember, I am assigning Khan Academy. This is going to be a work day today to help us get caught up on retakes we have to take from the last test. You can work on practice work and those retakes. That comes first. If you have all practice work and retakes done, then you work on Khan Academy. If you get finished with or you could do Khan Academy or working on the math packet. That math packet is due next Friday. Khan is due next Thursday. If you are all done with math, so nobody's done right now because everybody has brand new Khan Academy assignments. So we work on those first. Liam, you can go. We work on those first. Then if we're all done with that, you can go back and study for religion quiz that's tomorrow. You can make sure you have your social studies comprehension page done. You could do work for Mrs. Gregory. You could read a book. Notice how nowhere in there did I say talk with your friends. This is not social time. It is a work time. I will have people doing retakes, which is testing. We must be silent. This is not social time. If you're watching this video at home, I hope you are well, and I hope to see you soon. Have a wonderful day.